Hello, everyone, and welcome back. My name is Mr. Cobalt, and today I'm going to be going over acid-base reactions, also known as neutralization reactions. And so we need to start with what the definitions of acids and bases are. And one set of definitions are called the Arrhenius definitions of acids and bases. And there's another definition called the Bronsted-Lowry acid-base definitions of what an acid-bases are. That'll come later, but for now, the Arrhenius definition will suit us just fine. So for acids, according to the Arrhenius definition, are substances that produce an H plus when you throw them in water or in aqueous solution. Um, Bases are substances that are going to produce a hydroxide ion, OH minus, in water or in aqueous solution. And so those are going to be our definitions of an acid and base. An acid is something that produces H plus, and a base is something that produces hydroxide ions. Now, one thing I want to mention about the H plus, and I kind of talk about it here, is really what's going on is that an acid is going to release a hydrogen. So when it releases a hydrogen, it's going to be in the form of H plus. Now, H plus is just a hydrogen atom with its electron removed. Now, hydrogen atoms only have one electron. So when you remove the electron, all you have left is the nucleus. And in the nucleus is just the proton. So a lot of times you'll read and hear people refer to the H plus as a proton. And so I just want you to be aware that that's a common saying. We call this a proton because that's really what it is. And so really what's going on, so the acid is going to release a proton or an H plus or H plus ion, and that H plus is going to be picked up by the water. Now the H plus, we don't have H pluses or protons, bare protons floating around in water. They're going to be picked up by water molecules. And so that forms what is called the hydronium ion. And so a lot of times we'll write equations with the hydronium ion, or we'll write just H plus, right? So H plus and H3O plus refer to the same thing, which is the hydronium ion. So that's what's really in solution is this hydronium ion, H3O plus. But sometimes, we'll make it easier and less complicated, and we'll write H plus instead. But just be aware that if you see H plus, it's really H3O plus, the hydronium ion. Okay, so that's what's going on with the acid. And again, I want to bring in this idea of strong acid, weak acid. A strong acid is something that dissociates or ionizes, I should say, ionizes completely in water. So when you add, this is an example of a strong acid. So we have hydrochloric acid. When you add that to water, it's all going to separate. So the arrow is pointing only in this direction. So all of this is going to separate. The hydrogen is going to come off and be joined with water. So you get H3O plus, the hydronium ion, and then you get the anion left over. The chloride ion is left over. So that's a strong acid. A weak acid, again, is not going to ionize completely. It's only going to ionize a little bit, right? Just a small, tiny fraction of this is going to ionize. So some of this this is acetic acid. Some of the acetic acid is going to give off its proton here, its hydrogen. This is the acidic hydrogen. The way I know that this is the acidic hydrogen is because it's written first. A lot of times they'll write acids with the H first to identify that is the acidic hydrogen. And so this hydrogen is going to come off and join with water to form H3O plus. And then what's left over is your anion, the acetate ion. Now, this only happens a little bit, right? So most of your substance, most of the species in water is going to be in this form, and you're going to have a little bit in this form, in this form. And then there's equilibrium going on. So some of this is going to ionize into H3O plus and the acetate ion, and then some of this is actually going to kind of combine back. So the hydrogen is going to be taken back to the acetate ion to reform your acetic acid. So this is kind of going back in equilibrium, right? But most of the species is going to be in this form. So that's what's happening with a weak acid. So now we have other acids that are polyprotic acids. Remember that the acidic hydrogen, when it comes off, we call it a proton. So that's where polyprotic comes in. So an acid that has more than one proton or acidic hydrogen that can come off. And so we have diprotic acids, meaning they have two hydrogens that will come off. You have triprotic acids, so you have three hydrogens that are going to come off. So those are examples of polyprotic acids. And so here's an example of a strong acid. So we have strong acid. This is sulfuric acid, and it has two hydrogens. So they're written first, two acidic hydrogens. So in the first reaction, it's a strong acid, so it's all going to go in this direction. And so one of the hydrogens are going to come off, join water, and then you get the ion left over, so HSO4 minus, aqueous, and then you get your hydronium ion. So that's the first reaction. And then you have the second reaction, and now you don't have a strong acid anymore, you have a weak acid. So this proton is not going to come off very much, but it will a little bit. So some of the proton, some of the hydrogen will come off and join water, and then you'll be left with your sulfate ion. But then it's going to go back. So some of this is the sulfate ion will take back the hydrogen. You'll get water, and then you'll get your weak acid back. So your bisulfate, your bisulfate ion, or your hydrogen sulfate ion. So this goes back and forth. So this is a weak acid. So a diprotic acid like this one, the first reaction, when you lose the hydrogen, will be completely in one direction. So at the end, you're going to only have this. So this is not going to be in solution. All of this is going to ionize into this. So then the only thing you have in solution is this and this, right? Hydronium ion and your hydrogen sulfate ion. But then this, if you could bring it down here, can further react. So then some of this is going to dissociate or ionize. Some of this is going to ionize into the sulfate ion and your hydronium ion. So you're going to have mostly this in solution, along with a little bit of this and a little bit of this. And of course you have water in there as well. Okay, so that's your polyprotic acids. You can write the same thing, you can do the same thing with your bases. And so this would fit the definition of your Arrhenius base, right? So anything that when you throw it in water, it forms hydroxide ions. So you have NaOH and you have strontium hydroxide. Sodium hydroxide, strontium hydroxide. Both of them have hydroxide ions in them. So when you throw them in water, they're going to dissociate into the hydroxide ion and the positive metal ion. And so, of course, they're going to produce hydroxide ions. So these would be Arrhenius bases. Okay, well, what about acid-base reactions? Well, acid-base reactions or neutralization reactions are reactions where you are reacting a base and an acid together. So the way you do acid-base neutralization or acid-base reaction, you can also predict the products like you did with a precipitation reaction. If you remember from the precipitation reaction, the way you predicted your products was you had A, B plus C, D, right? And then you had to predict your products, and the way we did it was the inside ions went together because that's plus and minus. So that would be Cb. So then you would balance that equation to make sure it's balanced in zero charge. And then you would have your outside ions go together, Ad, because those are plus and minus. So you have Ad, and then you would balance that equation to make sure that it's zero charge. And then once you had it balanced, then you would look at your solubility chart and say, okay, well, did any of these form a precipitate? If they did form a precipitate, then you've got a reaction, right? So you write S for solid. If neither one of them formed a precipitate, then you have no reaction. Okay, same thing here. You could do the same thing with your acid-base neutralization reaction. So even though these are not ionic compounds, they will ionize into ions when you throw them in water. So you could do the same thing. Your base is an ionic compound, but your acids are molecular, right? But when you throw them in water, they'll separate and they'll ionize into ions. So you could do that inside ions, outside ions, same thing. So here, so if I want to predict what my products are, then I take the inside, right? So I have sodium and chloride. So I put the sodium chloride together and I balance the charge, so plus 1, minus 1, and that's going to be aqueous because according to solubility rules, sodium and chloride ions are aqueous and these are soluble. And now I can take the outside ones. I have hydroxide and I have hydrogen. H plus OH minus are going to come together and that's going to form water, H2O. Okay, so that is a reaction. A reaction is going on. I'm not forming a solid. There's no precipitate forming, but I am forming water. So my product in this case is water. So I'm going from aqueous solutions to water, right? So that's going to be a reaction. And so if I do my net ionic equation, the sodium and chloride ions are floating around in solution. They're not doing anything. They don't form a solid. So those are spectator ions. But the hydroxide and hydrogen, or the proton here, are players in the reaction. They're the ones that form the water. So if I write my net ionic equation, I'm going to have H plus OH minus giving me water. That's the net ionic equation for a acid-base neutralization reaction. Sometimes you might form a precipitate with this type of reaction, but most of the time your salt, the salt that you form is going to be aqueous. It's going to be soluble in water. So usually the only product you're forming is going to be your water. Sometimes there'll be gases formed, but that's for a later lecture or later video. Okay, so that's pretty much it that I wanted to cover for acid-base reactions. I hope this was helpful. And if you like this video, please share the video, like the video, make a comment in the comment section. Let me know what you think. Please subscribe to the channel and ring the notification bell so that way you can get notified by any other videos I put out. Thanks for joining me, and I'll see you next time.